안녕하십니까, 니꼬쌤입니다. And maybe you did not know this, but if you are a JavaScript developer that uses NPM, or if you are a Python developer that uses PIP, the chances of you getting hacked are quite high. When I say hacked, I mean getting your personal emails and accounts hacked, your private files being read, copied, or deleted, private keys and environment variables being leaked, or even getting a full-blown RAT, remote access Trojan, that can control your mouse, keyboard, and take screenshots. Developers from other languages are at risk as well, but because of how massive the Python and JavaScript ecosystems are, attackers are targeting developers on these communities much more aggressively. So today we will learn how this attack works. We will take a look at some of the malicious code written by the hackers, and at the end we will learn how to protect ourselves if such thing is even possible at this point. The most valuable asset a developer has, apart from a mechanical keyboard, is time. This is why when a developer has a task, they will first search and see if someone on the internet has already written code to accomplish a similar task. They will either find some code that does something similar to what they need, or they will find a package that does exactly what they need. So they can just install the package, save a bunch of time, and keep going. Being able to install and use packages that somebody else wrote, instead of writing the code yourself, saves a lot of time. But sometimes we as developers overdo it and end up depending way too much on third-party packages. The left path issue was proof of that. Years ago, a developer broke the JavaScript world when he unpublished a package he wrote that only had 11 lines of JavaScript code. The package was called left path, and all it did is add left padding to a string of text. For example, this is what it could do. You would give it a number, a maximum length, and it will format the number, adding zeros to the left. Simple. This is the actual code. These 11 lines of code were being downloaded more than 2 million times per month. It was depended on by many other projects. Because this package was unpublished, projects like Babel that are used by all Silicon Valley broke as well. The left path issue highlighted just how much developers reuse each other's code, and how liberal we are on installing and depending on external packages to save a bit of time rather than writing code by hand. It also highlighted how interconnected everything is and how much packages depend on each other. And of course, attackers and malicious actors took note of that. Enter supply chain attacks. A supply chain attack is a kind of attack where a malicious actor doesn't try to hack your server directly. Instead, the attacker poisons and compromises the software components that you use to make your software run. Using a supply chain attack, an attacker can compromise your server or the machine and credentials of the developer itself. According to a research paper published in 2019, the installation of a single NPM package typically requires the installation of 79 third-party packages the desired package relies on. In addition, the installation process involves placing trust in 39 maintainers that you don't know anything about. That creates an incredibly large surface area for the attack to take place. One way the attack could happen would be by taking control of the accounts of the people that publish the code that everybody depends on. There is a package called for each, whose code is this small. This package is downloaded more than 3 million times per week and is depended on by 36,000 other packages. The special thing about this package is that a security researcher found out that the account controlling it was created using an email from a custom domain name, meaning not an email from Gmail or Naver, but their own domain name, like nico@jsdev.com, for example. What the researcher found out is that the domain had expired. It was back on sale. So the researcher bought the domain and could effectively take over the account by sending a reset password email to the email now owned by him. Thankfully, the security researcher only did that to bring attention to the issue. But if it was a malicious actor, he could have easily pushed a silent update to the library with destructive code that would have been downloaded millions of times. In the case of an attack where the account of the developer is compromised, there is very little we developers can do apart from hoping it doesn't happen and keeping our dependencies to the minimum. There is another attack vector where developers can get their machines compromised, as well as their passwords and credentials, and that is by installing a package pretending to be the real one. For example, MathJS is a very popular math library. Some days ago, the package MathJS-min was uploaded to NPM. On the software world, -min means minified, a smaller version of the package. Compressed, a version that takes less space. So it makes sense that a developer that wants to make the application size as small as possible will choose the -min version out of habit. Attackers know this, and this is why the MathJS-min package was actually malware. It was slightly modified to look and feel like the MathJS package, except that it was also stealing Discord tokens. Here you can see how the function square root number was modified to call another function that looked for a Discord token on the browser of the user and leaked them to the attacker. Getting the Discord token stolen is not as bad if you really think about what is going on and what the attacker could have done. We as developers are downloading code from strangers, and we are running that code in our computers without actually taking a look at what the code could do to our system. This is made worse by the fact that because of how NPM works, when you download a package from the internet, that package can run pre and post installation scripts. The package can run code in your machine before and after the installation happens, on the background, silently without you noticing. Installation scripts can do lots of harm, like in this code, which was found on an install script of a malicious NPM package. Here the attackers are taking your package.json file, which contains information about the project, and your .env file, where private keys and tokens are stored, and sending them to their server. You can get beaten by an attack like this if you don't pay enough attention at what you are installing and you spell the name of the package wrong. This is because of a technique attackers use called typosquatting. Typosquatting is when attackers upload their malicious code to packages named very similar to legit packages, hoping for people to make a keyboard mistake and download the malicious code. For example, Selenium and Beautiful Soup are two very famous Python packages. And so what attackers did is to publish packages with these names, which as you can see are misspelled versions of the original packages. But they are spelling errors that are hard to catch and easy to make, especially in the case of Beautiful Soup. What all these packages contained was this code. And what this code did is to create a browser extension that runs this code. That browser extension detects all the copy-paste events, and when the user has copy-pasted a cryptocurrency address, it intercepts the event and replaces what the user has copied with the cryptocurrency address of the attacker. There are many other examples of what malicious code can do. There have been packages caught installing remote access trojans, keyloggers, downloading code from dodgy URLs, and more. So how can we protect ourselves from a supply chain attack? First of all, trying to only install the most necessary third-party packages. The less packages we install, the less surface area there is for an attack. Then, to not be a victim of typosquatting, make sure that you spell the names of the packages you are trying to install correctly, and don't trust packages that end with the word -min or any other weird extensions unless you are sure they are published by the same developer. You can increase your security even more by telling Node.js and NPM to not run pre and post installation scripts. To do this, you can append the --ignore scripts flag next time you are installing a package like this. When you do this, this tells the NPM CLI to skip the execution of pre and post installation scripts. But keep in mind that this might break the installation process of packages that make use of the pre and post installation scripts for legitimate reasons. Thankfully, using installation scripts is discouraged and most packages don't use them anymore. But unfortunately, that option is always there for hackers to use it. You can also upgrade to the newly released version 20 of Node.js. This version comes with a new experimental feature that allows you to restrict the permissions your software has when running. Using the -- experimental permission flag, you can give or deny the program and its packages read and write access to your file system. If you use GitHub, pay attention to the Dependabot alert. Dependabot is an automated system that runs for all the code hosted on GitHub. This bot will periodically scan your code and let you know when you are using a dependency that has a security the issue. And it will automatically create a pull request in your repositories to update it. And finally, if you want to go full paranoid like I did and you don't want to trust anything, you can use Docker combined with VS Code to run all the projects you are working on inside of a container that is isolated from your personal files. Let me know in the comments if you would like a video on how to set that up. That's it for this video. Now it's your turn to let me know what do you think about this issue. Were you aware of supply chain attacks? Do you think it's possible it can happen to you? Let me know in the comments. I'm gonna be reading them right now. And don't forget that if you want to learn things like JavaScript, Python, React, React Native, Go, Dart, Flutter, among many others for absolutely free, all you have to do is click the link below to join any of our many free courses that you can take right now for absolutely free with me. Click the link below and I will see you there. 오늘도 감사하고 사랑하고 다음에 봐요. See you on the next one. Bye bye.